Hey everyone, here's another inequality to solve, and we want to graph the solution on the number line. Doesn't look too bad. 4 minus 4x is less than or equal to 20. So to solve the inequality, we get x on one side and number on the other. Just like an equation is what we're going to do. We're going to first get rid of that 4. It says 4 minus 4x, so if we subtract 4 from both sides, then the 4 minus 4 cancels out. We have negative 4x less than or equal to 20 minus 4 gives us 16. So now negative 4x is less than or equal to 16. Again, like an equation, get rid of that negative 4 by dividing it out. Here's where we have to be careful. Anytime we divide or multiply both sides of an inequality by a negative number, we have to flip the direction of the inequality. So that means that this is going to turn out to be, since the negative 4's cancel, we have x is greater than or equal to, and 16 divided by negative 4 is negative 4. Now you might wonder, why in the world do we flip that inequality? It doesn't seem intuitive. I think I can convince you that it makes sense if I show you an example that doesn't involve a variable, but just any other inequality. For example, like this one, 2, no, just don't use 2. Let's say 4 is less than 10. Nobody's going to argue with me on that. There's no variable there, so we can clearly see that's a true statement. If we divide this side by negative 2 and this side by a negative 2, since we're doing the same thing to both sides, we would expect the results to still be true. But watch what happens. 4 divided by negative 2 is negative 2. 10 divided by negative 2 is negative 5. Well, if I leave the less than symbol there, it's no longer true. Negative 2 is not less than a negative 5. So just because we divided by negative means that in order for that to still be a true statement, we have to change the direction of the inequality. Negative 2 is greater than a negative 5. And the same thing would happen if I had multiplied by a negative 2 instead of divided. I would end up having to flip the direction of the inequality to keep the statement true. Now, that rule must apply whether I've got a variable here or an actual number, because after all, x is just stands in for a number. So the same thing has to happen for any inequality. All right, so the solution is x is greater than a negative 4. We have to give the solution in interval notation, and we have to graph the solution. So I think it's helpful to graph it first, and then from the graph figure out the interval notation. X is greater than or equal to a negative 4. Now let's say there's 0, so negative 4 has got to be over here. X is greater than negative 4, so I'm going to shade to the right. But x could also equal a negative 4, so I'm going to put a bracket on top of 4, or on top of the negative 4. So that's why the bracket's there. The bracket's there because it's a greater than or equal to. And then we shade to the right and put the arrow to indicate it goes forever. The interval notation is going to fall right from the graph here. So the interval is going to have a negative 4 on the left side of the interval. It's going to have a bracket to match the bracket on the graph. And then the right side of the interval is going to be positive infinity, because we're heading into the positive direction forever. We always have parentheses on infinity, or next to infinity. So there's the solution in interval notation, and there's the graph.